This is video 19. In this video, we conclude the toolbox by proving that the decomposition of a positive extremum path is always positive. Consider a simple B-infinite window W which is not a cycle. This window is in gray. The graphs G1 and G2 are the cut of the grid associated to this window. Consider a simple path P such that its first and last positions belong to the window W, and here is the decomposition of P in extremum arcs in the graph G1. This decomposition is made of 6 arcs. We do not draw the path P. In this example, we do not suppose that P is extremum. Consider the first positive arc of the decomposition. In this example, we consider that this arc is A2, thus all the previous arcs are negative. In our example, the arc A1 is negative. The negative arcs are drawn in blue while the positive arcs are in red. The case where there exists no positive arc is dealt in the article available online. Now consider the last positive arc of the decomposition. In this example, we consider that this arc is A4, thus all following arcs are negative. In our example, A5 and A6 are negative. Since A2 and A4 are positive and since P is positive, then all arcs between these two arcs are positive. This result was proven in the previous video. Now consider the finite dual segments. The dual segments D2 and D3 are between two positive arcs, and since P is positive then these two dual segments are positive. This result was proven in the previous video. Now consider the dual segment D1. This segment is between a negative arc and a positive arc. Then whatever is the direction of D1, the beginning of the path P belongs to the interior of D1. This result was discussed in the previous video. In our example, this dual segment is positive. Now consider the dual segment D4. This segment is between a positive arc and a negative arc. Then whatever is the direction of D4, the end of the path P belongs to the interior of D4. This result was discussed in the previous video. In our example, this dual segment is negative. Now consider the dual segment D5. This segment is between two negative arcs. Then if D5 is positive, then the beginning and the end of the path P belong to the interior of D5, but the beginning of P is in the interior of D1 and the end of P is in the interior of D4. Then the dual segment D5 is negative. Here is an example of a path P which matches the direction of the arcs and the direction of the dual segments. To summarize, if the path P is positive, then the arcs and the dual segments which are in the beginning and in the end of the decomposition are negative, while the arcs and the dual segments which are in the middle of the decomposition are positive. Now let's start again, but this time, we assume that the path P is positive and extremum. Then the first position of the first arc is the first position of the path P. This means that the first arc is positive. Similarly, since P is extremum, then the last position of the arc A6 is the last position of the path P. This means that the last arc is positive. Then all arcs are positive. Then all finite dual segments are positive. The decomposition of an extremum positive path in extremum arcs is positive. Here is an example of a path P which matches the direction of the arcs and the direction of the dual segments. Before concluding the toolbox, we present some applications of these results. Now we consider a simple finite path P whose first and last position do not belong to the window. Now we consider an extremum positive arc A of G1 which is a subgraph of the path P. Now consider the window W' associated to the arc A and its cut of the grid made of G3 and G4. Let's zoom on the last position of the arc A. The window W' goes from the north to the east. The path P goes from the north to the south. Remark that the edge between P98 and P99 is strictly on the right side of W'. In this case, the edge between W27 and W28 is strictly on the left side of P. In this example, we have studied only one case. The other cases are studied in the article available online. We end this video by generalizing the definition of a decomposition in extremum arcs to other paths and in particular to infinite paths. Consider a simple B-infinite window W which is not a cycle. This window is in gray. The graphs G1 and G2 are the cut of the grid associated to this window. Consider a simple finite path P. Here its first and last positions do not belong to the window W. Then we consider the first index such that P intersects with the window. We also consider the last index such that P intersects with the window. The decomposition of P in extremum arcs in G1 is the decomposition of the segment of P between these two indices. Later, we will need to compute the decomposition in extremum arcs in G1 of an infinite path, but we consider a specific setting. In this setting, the position P0 belongs to the window and P starts in this position. Now we suppose that there exists a finite index J2 such that Pj2 is the last intersection between the path P and the window W. Then the decomposition of P in extremum arcs in G1 is the decomposition of the segment of P from its first position to the index J2. In our example, there exists an index J1 such that the segment of P from its first position to the index J1 is the extremum path extracted from P. By definition J1 is less than J2. Now consider the window W second associated to the path P and its cut of the grid made of G5 and G6. In our example, the segment of P from J1 to plus infinity is a subgraph of G6. Then in this case, the decomposition of P in extremum arcs in G1 is the one of the segment of P from its first position to J1. Since the extremum path extracted from P is positive, then this decomposition is positive. By the previous remark, the dual segments from D1 to DL are on the left side of P. This remark is true when the length of the first arc is at least 2.